Welcome, 7th grade. Sorry, I was on the wrong slideshow there. All right. Equivalent fractions and decimals. So we're going to learn how to go from fractions to decimals or decimals to fractions. We're going to work on that in today's lesson, and hopefully we get moving here rather quickly. All right, write each fraction in the simplest form. So up here, it's important that we realize we're dividing by a fancy one, which is 4 over 4, and we get 1/3. Over here, it's important that we realize we're dividing by 2 over 2, and we get 9 over 23 for our answer. All right, here I see that I can divide by 21 over 21, and I get 1/3 as my answer. Over here, it's an improper fraction, but we can still divide by 2 over 2. And, actually, I want to change that to 4 over 4. So I'd have 25, and then 4, that would be 1, that would be 18. And I think from there, that is the answer we have. 25/18 or 1 7/18. That is correct. All right, problem of the day, well done. To write fractions as decimals and decimals as fractions, and determine whether a decimal is terminating or repeating. Terminating means to end. I terminate your job. Your job ends. Repeating means goes on forever. You've seen it in situations like this. 0.333. They put the little line over there. That's the repeating one. In baseball, a player's batting average compares the number of hits with the number of times the player has been at bat. The statistics on the next slide are for the 2006 Major League Baseball season. All right. So, Miguel Cabrera, 195 hits, 576 at-bats. They take the hits divided by the at-bats, and they get his batting average, which I just circled, 0.339. That is the same way you can figure your grades. Number right divided by the number total. Ichiro Suzuki had 224 hits, 695 at-bats, and you can see his batting average right here. Okay? So we can compare those two. The average then shows us very quickly who is batting slightly better than their opponent. All right? To convert a fraction to a decimal, divide the numerator by the denominator. So, numerator divided by the denominator. 1 divided by 4. We know the decimals right here, and we can place zeros to help us get the answer. All right, because adding zeros to the end doesn't change anything. 4 will not go into 1. 4 will go into 10 twice. There's 8. That's 2. You bring down the 0. 4 will go into 20 5 times. It came out to 0. We have our answer. All right, they do their division. Oh, wonderful, 0.25. All right, 9/5, you can take 9 and you can divide it by 5. All right, don't forget the decimal right there, and I'd probably add a number or maybe 2. 5 will go into 9 one time. Subtract, that's 4. Bring down the 0. 8. Do not forget to take that decimal up to the top. 1.8 is our answer. Let's see if they agree with us. They do the math that we did, and they get the answer that we got. Well done. Here, we'll let them do the work. It will go there. They do the subtraction. Notice they bring the decimal up. They do the work, do the subtraction. Hey, we keep coming up with 20. This is an example of one that would repeat, because every time we're going to get to 18, and we're going to subtract, and we're going to get 2. We put a 0 back up, we get 20. This will be repeating. Round to the nearest hundredth, tenths, hundredths. All right. So we round 1.67 to the hundredths. You can use a calculator to check your division. All right. 1 divided by 4 is 2.5 or 0.25. 9 divided by 5 is 1.8. And 3 divided by, or 5 divided by 3 is 1.66. Okay. Here, if you know some of these already, you're doing great. 3/4 is 0.75. Think of it like a quarter. Oh, I have 4 quarters make $1. 3 of them, 0.75. 6/5 is 1.2. Another one that I know, we can do the math and they'll show it to us. Now, 7/3 is 2.3 repeating, or they're telling us to round to the hundredth, so it's 2.33. All right, I know these from working with them long enough. You can always do the division out and have it help you. All right, that one terminates, it ends, 0.75. This one terminates and ends. We get 1.2. I put an extra 0 on there for what reason? I don't know. This one would continue repeating. Notice how we have the 10 minus 9, then 10 minus 9 pattern. We round to the hundredths and we get 2.33. All right. You can do division. Now we're working on knowing if it's terminating, that means it ends. All right, the decimals 0.75 and 1.2 in example 1 are terminating decimals because the decimals come to an end. The decimal 0.333, notice they do the dots, that means goes on, is a repeating decimal because the decimal repeats a pattern forever. You can also write a repeating decimal with a bar over the repeating part. Oh, something like that. This would be if 3's repeat forever. You can see the 3 has that. If it's 8 and then 3's repeat forever, notice the 8 does not have one, but the 3 does. And then 7, 2, 7, 2, 7, 2. Both numbers have it because both numbers repeat in that same AB pattern. All right, write each fraction as a decimal. 0.8. I know these because, 5, each time you have a number, it's 0.2. They'll do the division. All right. 2 times 2, that gets 8 tenths. 8 tenths. Oh, it says it. That's 8 tenths. You could still do the division of 4 divided by 5 and get your answer. Bring the decimal up, 0. That will go into 40. 8 times 0.8 is our answer. 37. Write each fraction as a decimal. We could do the division. It will work. Watch this. 37 divided by 50. Okay, so that'll go in there 0 times. It'll go in here 7 times. So that will be 200. All right, that will be 4 times 0.74. Notice what they did. They multiplied by a fancy 1, the 2 over 2. 100 on the bottom, 74 on top. That's 74 hundredths. That is 74 hundredths. Sometimes using the fraction to get the answer. So if you can get to a 10, 8 tenths. I know how to write that. 74 hundredths. I know how to write that. These fractions, if you can get to a 10 on the bottom, or you can get to 100 on the bottom, they may make it easier. All right, write each fraction as a decimal. 0.6. All right, they're going to take it times a fancy 1. 2 times 2. Watch, they get to 6 tenths. You can still divide. 3 divided by 5. It will work, but that's a lot more work. Okay, 0. Gracious. 6. And that's 30. 0. 0.6. You can get it either way. 6 tenths like you see right here. You can do the division. See 6 tenths on the division problem. Or you can know it. All right. 18 over 25. I bet they take it times a fancy 4 or fancy 1. 4 over 4. 72 over 100 is 0.72. Oh, that's what it is? Watch, 18 divided by 25 will get us the same answer. 7 times 25 is 5. 14, 17. 5 and 0. 2 will go into 50 twice. Or 25 will go into 50 twice. There's 0. 0.72. All right. Now, write each decimal as a fraction in simplest form. So, there is a cheat. If you say it like we're supposed to say math problems, you have no problem doing what you need to. So we have to work on saying things the correct way, not 0.018, which I really like to do. But if I look, tenths, hundredths, thousandths, 18 thousandths. Oh, I put 18 over 1,000. But they said simplest form, so I divide by 2 over 2, and I get 9 over 500. Okay? So if we say it correctly, the place value will give us what the fraction looks like. All right? 9 over 500, 18 thousandths. Yes, this one. 1 and 55 hundredths. 1 and 55. 1 and 55 hundredths. Oh, hundredths, you put it over 100. Because tenths, hundredths. All right? I see I can divide by 5 over 5. 11 over 20. Oh, 1 and 11 twentieths. Don't forget to keep that whole number with it. Let's see how we did. 1 and 11 twentieths. All right? Notice they're going to do it different than I did. They made it into an improper fraction, then did it at the end. I simply kept the 1 out in front and had the 55 hundredths. That works as well. Then you only have to reduce a smaller number. Okay? Here, if I say it correctly, tenths, hundredths, thousandths, 15 thousandths. I divide both by 5, and I get 3 over 200. And that is my answer. They'll show you the big fancy work here. Oh, they did the same thing. I will show you my way, and we'll see it next to theirs. 1, and there was no need to have this 0 here. 3 tenths. Oh, problem done. 1 and 3 tenths. Let's see what they do. Oh, they did reduce. We got the same answer. If you knew there didn't have to be a 0 there, that problem becomes so much easier. A football player completed 1,546 of the 3,875 passes he attempted. His completion rate. Write your answer as a decimal rounded to the nearest thousandth. Okay. So here's the fraction way over here. You see that? You do the division. Hit enter. This one would be crazy to not use a calculator on. Tenths, hundredths, thousandths. Round back. 0.399 would be our answer. Completions over total passes. His completion percent was a 39.9%. All right. So a professional quarterback completed 2,830 of his 5,186 passes. So again, we've got our chart that they're going to make for us. Oh, how nice of them. We took complete passes over total passes. We do the division. We're rounding to the thousandths again. We go back, and we get 0.546. Reading what number to round to is important. Please pay attention to that, my 7th graders.